Alright, for today's video we are talking about continuous random variables. Essentially that means the same thing as our normal distributions or bell curves. Now the main thing we have here is empirical rule. Now empirical rule tells us that within so many standard deviations of the mean, a certain percent of our data will always lie. So 68% of our data will always lie within one standard deviation of the mean. So if you think, here's our mean, from one standard deviation to the left and one to the right will always hold 68%. Now, 95% will always lie within two standard deviations of the mean. So if here's our mean, here's our second standard deviation. So all the way from here, all the way to here will always hold 95% of our data. And then thirdly, 99.7% will always lie within three standard deviations of the mean. So here's our mean. If you think there is a standard deviation length, so there is three standard deviations to the left and three standard deviations to the right. This is the main focus of continuous random variables. And if you think, the essential question we're going to be going through today is how does the value of the mean and standard deviation change the shape of a normal curve distribution? And that's what we're going to be answering today. So, we will be going through, we have some definitions to do first. First up, the definition of a normal distribution. The main thing is a distribution of data that is bell-shaped, like the one you saw on the previous slide. It is symmetric where the left side looks like the right, just a mirror image, and it follows the empirical rule, or the 68, 95, 99.7 rule. Now, a standard normal distribution is what we're going to be primarily using. Now, this is a normal distribution with a mean of 0 and a standard deviation of 1. When we're talking about this, we're talking about z-scores, and we will get more into that next video. So for today's, we have two examples. Here is example number 1. Take a minute and read. Okay, now first off, it wants us to identify the mean or the middle value of each curve. And when we do that, we're going to go through and look for where the top part of the curve touches that x-axis below and just pretend that's a straight line. So 10. So our mean of curve A would be 10. Curve B, if we do the same thing, would be 12. That's pretty easy. That's just looking on our graph. The next part, determining the standard deviation. Now remember, a normal distribution has three standard deviations. And if you think about it, the third one almost always just about touches the graph. So we need to find a place where this graph just about touches our x-axis. So right here, it looks at about here. Now, since there are three standard deviations to each side, we're going to subtract our values and divide by 3 to determine what our standard deviation is. So if we go through, 10 minus 7 is 3. And then we have to divide that by 3 for 3 standard deviations. We end up with a standard deviation of 1. So let's go through and let's do the same thing for curve B. The same thing for curve B. It stops about right here at 9. We do the subtraction. 12 minus 9 is 3. 3 divided by 3 is 1. So our next thing is that it wants us to compare the two graphs using their mean and standard deviation. So I'm going to go through and get my text tool. So we could say that curve B has a larger mean, but they have the same standard deviation. Or essentially, that means they both have the same consistency. Which is really pretty cool that we can find that out just by doing some things and looking at a graph. So we're going to go through and look at a second example now. Take a minute and read. Okay, we have two curves, curve A and curve B. This time if you look, this one has a really high top of its mountain, and down here we have a very low top of its hill. So first off, we need to identify the mean. Remember, mean is that middle value. So here we are, middle value going straight down. Looks to be just about 7. Do the same thing for B. And look, I didn't have to draw a second line. It already went through the middle at 7. So that's actually pretty cool. They have the same mean. So standard deviation. So for curve A, I'm looking for where it just about touches which is about right there, about 5.5. So when we do some subtraction, 7 minus 5.5 should be 1.5. Then we divide that by 3 standard deviations because we want to find how big 1 is. And when we do, we end up with 0.5. So we're going to do the same thing now for b. So starting at our mean, we're going to look until we see just about where it touches, which is about right here at 2. We're going to subtract our mean minus that. So 7 minus 2 is 5. Divide that by 3. So 5/3 would be our standard deviation. Or if you think about it as a decimal, about 1.67. Now our next part wants us to compare the two graphs using our mean and standard deviation. So if you think about it, we already said that they have the same mean. That doesn't always happen. Now let's look at our standard deviations here. On this one, our standard deviation is 0.5, so it's really, really consistent. It's really close together. If you look at our mean of curve B, our standard deviation there, 5/3, it's 1.67. That's pretty spread out. If you look at the number or if you look at the curve. A, if you can see here, it's really tight to get between one to the other. For curve B, it's really spread out. Sorry about that. Then we could say curve A is more consistent than curve B because it has a smaller standard deviation. It's really pretty cool.